Assalamu alaikum wa rahmatullahi wa barakatuh. This is the first lecture of the series of lectures speaking about basics of research design. Our lecture is divided into two parts. First part will speak about observational studies, descriptive studies, and second part will speak about sampling technique. This lecture is prepared by Dr. Azmy, Professor of Public Health and Preventive Medicine, and represented by Dr. Enas, Assistant Professor of Occupational Medicine, Public Health and Community Medicine Department. And we can know the type of the study according to if the investigator assign the exposure or intervene with the exposure. If there is intervention, it's called experimental study. That's why the other name is interventional study. And according to if the investigator randomly allocate the participant between 2 or 3 groups, if yes, it's called randomized control trial. If there is no random allocation of the participant, it's called non-randomized control trial. This appear in the right part of the slide. On the left part of the slide, we can see that the investigator didn't assign exposure, or he didn't intervene with exposure. That's to say he only observe the participant. That's why the name is observational study. If there is observational in the observational study, if there is no comparison groups, it's called descriptive study, and this is our lecture today. But if there is comparison groups, 2 or more, it's called analytic study, because the investigator compare these 2 groups and the types of analytic study, either case control study or cohort study. So first of all, the descriptive study, which is the first 2 in water. What is the uses of descriptive study? As we say, descriptive study from its name to describe the pattern and the characteristic of a disease or health problem. Number 2, to formulate, not testing, only to formulate, just like suggestion, the research hypothesis. And the third use is allocate health resources and to target the high risk group for health education, screening and prevention program. So descriptive study only to describe. There is no analysis here. Only to describe the pattern of disease, formulate the research hypothesis, and allocate the health resources. Types of the descriptive study may be only on one case, it's called case report, more than one case series, and on the group of people, not on individuals, it's called ecological study, and snapshot on group, large group of people, is called cross-sectional study, and last one, longitudinal study, which is prospective study. First one is case report. Case report means detailed presentation of single case. That's why it's called case report. So it is report about one case, reporting new finding. For example, a newly describing disease or unexplained new therapeutic effect. And this is examples of the case report. Can we see here, for example, case report on acute pancreatitis following medical abortion. So this is like abnormal finding. That's why if they find abnormal finding in one case, they write this abnormal finding and report about it, calling it case report. Second one in the descriptive study is case series. Case series means we describe series of cases, like number of similar cases in one report. And it may indicate the start of an epidemic. For example, if you are in your clinic and find more than one case coming and they have similar symptoms and signs, and you didn't see the similar symptoms since before, so this indicates start of epidemic, and this major trigger for further research. You just describe it and later on further research can do analysis. The disadvantage of the case series, of course, it is liable to many bias related to subject selection, because we select the cases which have similar cases only. And this is example. And this is another example. For example, like histopathology of severe childhood asthma case series. Like the investigator find a severe childhood asthma in more than one child, and he did histopathology for these all cases and publish it in the form of case series. Then the third one in the descriptive study is correlational or ecological study. What's meant correlation? Correlation means finding association. So it is look for association between. Here we can't find association between individuals. No, we find association between exposure and outcome in population rather than individuals. For example, if we try to find association between mortality from chronic heart disease and per capita sales for cigarette. In this case, we don't do the study on individuals, but we instead use the already collected population data, for example, vital statistics or census or national health survey. Other example to find the high incidence of myocardial infarction and consumption of dietary fat and fast food. The third example, and this is very nice example, for example, if we find the antenatal care, efficient use of antenatal care, we try to detect if there is good use or efficient use of antenatal care in healthcare setting, and also from the record we find the maternal mortality rate. Of course, if we in this case we find the negative correlation between both parameters. And this is example of the ecological study. The fourth type is the cross-sectional or prevalence studies. It's named prevalence because we detect prevalence from it. Observational study that carried out once is cross-sectional study, and it's characterized by it is snapshot of the population at single point of time. We detect the exposure and the outcome in the same setting. We don't follow the target group. We don't see them in more than one setting. Only in one setting we ask them about the exposure and also about the outcome. So we can determine if the exposure precedes the disease or not, as it is both detected in one time. It measures the prevalence, not the incidence of the disease, because the prevalence means the occurrence of new and old cases. So in this setting, in the snapshot or in the one setting, we detect the cross-sectional, we detect the disease. So we detect that, for example, the occurrence of diabetes mellitus among students of a certain school. So in this setting we detect how many students have diabetes now, but we can't detect that the newly diagnosed cases, which means the incidence of the disease. So in cross-sectional or prevalence study, we detect the exposure and outcome from one setting. Uses of cross-sectional study, as we say, it's called prevalence study, so we detect the prevalence rate of chronic disease. Also, we can find out the disease load in the community and its distribution in subgroups. We can do screening for unrecognized cases. Also, we can do detection of association between risk factor and disease. طيب, let us say the example to make it clear. Example for cross-sectional study, the cross-sectional study to detect association between coronary heart disease in relation to physical exercise. So in this case, we go to certain people, for example, as I said to you, students of fourth year medical school, and distribute questionnaire for them and detect ask them about their physical exercise, and also ask them about coronary heart disease or diagnose if they have coronary heart disease. So in one setting, we diagnose coronary heart disease either by questionnaire or even by investigation, and also we find out their physical exercise. So from this setting, we know the prevalence rate of this chronic disease. For example, if they are 1,000 students, we find out that 100 of them have coronary heart disease. So from this one, we find out the prevalence rate of coronary heart disease. Also, we can find this disease load in community and its distribution in subgroup. In the same way, we know the disease distribution if we do this research among all the years of medical school. We can know that prevalence or the disease load of this coronary heart disease among each year. Also from this one, we can do screening of unrecognized cases. Of course, some cases they know that they have coronary heart disease, and the other cases they don't know, and only they find out that they have coronary heart disease from the screening done during the research. The last use is that we detect the association between a risk factor, which is coronary heart disease, and risk factor is physical exercise or lack of physical exercise, and the disease, which is coronary heart disease. As an example, obesity in relation to diabetes mellitus, also thrombophlebitis in relation to use of oral contraceptive pills. And this is example of a cross-sectional study, prevalence and determinant of obesity, a cross-sectional study of an adult northern Nigerian population. They did cross-sectional study, snapshot study, one setting for the adult northern Nigerian population, and for in this setting, like they examine each one only one time. From this examination, they find out the prevalence and determinant, means like the risk factor of obesity among them. What about advantages and disadvantages of cross-sectional study? Its main advantages is it is useful for studying chronic disease or chronic conditions, as we see the patient only one time. So this time it's good to detect, or we can't detect acute condition, we can detect only chronic condition. On the other hand, it's not useful for studying acute diseases or disease with seasonal variation, because it come and go without detection. Also with highly fatal diseases, because person die without detection. We can't take a good decision or a good picture about the disease. Also about the rare diseases, because we can do cross-sectional study about many cases, and because this rare disease we can't find it among the target population. The advantage also is that there is no follow-up. It is relatively easy, quick, and cheap, inexpensive. We can estimate prevalence rate, as we said before, and also the exposure proportion. Exposure proportion means the proportion of the population who are exposed to certain thing, like the exposure proportion to smoking, exposure proportion to lacking physical activity, exposure proportion to drinking green tea. Okay, so it can estimate the prevalence rate, like proportion of people who have the disease, and also proportion of people who have certain exposure. But on the other hand, there's a disadvantage is that it can't estimate the incidence rate. Why? Because we see this population target group only one time, each one time. So we can't detect the occurrence of the new condition or new disease. From the advantage also, it is good for generating hypotheses about cause of disease, like it only suggests the disease, suggests the cause of the disease. But of course we can't like test the hypothesis, because we don't do comparison. and the disadvantages is it can't determine if the exposure precedes disease or not, as we determine both in one setting. From the advantage is it is a first step to develop causal association. We can't say, for example, the taking excess amount of sugar in our food is the cause of diabetes mellitus if we did it from the cross-sectional study. But because we don't know what come first, if the exposure first or the disease first, but it is a first step. We can just generate hypotheses about this condition. And disadvantages that there is no differentiation between cause and of the disease and factor associated with the disease. As we say, we can't find causal relationship. It's only factor associated, like factors occurring during occurrence of the disease, but we can't decide or we can't say exactly that it is a cause of the disease. The last one in the descriptive studies is longitudinal or instance studies. From its name, we can detect the instance from this study as we do repeated observation or follow-up in the same community over prolonged period to identify new cases of disease. Follow-up and re-examination have the following problem. Why we can't do this for all population? Because in this case we can do loss of, or we can lose to follow up some cases, and some people will not continue to follow up. Also because the difficulty in maintaining standard and stability of clinical and laboratory examination over long period of time. For example, if we detect the diabetes mellitus in certain population, we detect the diabetes mellitus this year by fasting blood sugar. Next year we can't find the kits, or we can't we don't have enough resources to do this test, so we do it by examining the urine only. So in this case, there is difficulty in maintaining standards and stability of the clinical and lab examination. And as I said to you, too, loss of follow-up, like we start by 100 case or 100 population, and after 1 year this 100 became 90 because 10 population decided not to continue. They feel bored or transfer to another country, for example. So it is very useful, but it has disadvantages. Type, it is used to measure the incidence rate, as we do in this case follow-up or repeated observation. Also, it is useful because it gives the natural history of the disease and its final outcome, like case fatality or survival, as we follow them from the beginning till the end. Also, it's useful to detect the risk factors of disease, because we examine the patient or the groups more than one time, so we can know, or we can find out which occur first, is outcome occur first or the disease come first. Like epidemiology of insomnia, it is a longitudinal study of UK population. They follow a certain group for a long period of time, and they examine them more than one time, and from this examination they tried to find out the epidemiology of insomnia. Another example. So, data analysis and descriptive studies, we find out the types of descriptive studies, starting from case report, case series, ecological study, cross-sectional study, and finally the longitudinal study. After we do this descriptive study designs, we should answer 5 basic questions starting by W's. What is the condition of condition or disease being studied, who has a disease, when is the condition common or rare, where does or does not disease or condition arise, and why did condition or disease arise. So what, who, when, where, and why. The second part of our lecture will speak about sampling from population. So in the beginning, what's meant by sample? Sample is a subset of population that is used to gain information about the entire population, as each investigator wants to do his research on the entire population to generalize this result. But of course it is difficult and impractical, as it takes a huge amount of money, time, and effort. So instead we do sampling, and the good sample will represent the population well. So the advantages of sampling is to lower cost, save time, provide more intensive and accurate investigations and information. Also, it eliminates bias. Bias is systematic difference between the characteristics of the people selected for the study and for the characteristic of those who are not. So as I say to you, each investigator wants to check for the whole population. It's called the theoretical population, the people who do you want to generalize to. Of course, we want to generalize our information or our results on the population who are living now on the earth, who lived before, who will come later on the earth, but it is theoretical. We can't do this. So instead we do and define the study population, that people who can you get access to. But of course, because of a huge amount of money, effort, and time, as we say, we can't do our research on the whole study population. Instead, we can do sampling from this study population by taking sample. And this sample the people who are actually in our study, and we use from this sample from this sampling technique the sampling frame. So the characteristic of population is name parameter. So name parameter is a characteristic of population, and the characteristic of our sample, the people who are already in the study, is named statistic. Our rule or our hope in the research to say that our statistic is close to the parameter to generalize the result coming from our research on the whole population. So what is the properties of a good sample? Of course, not all samples are good samples. The properties are to be adequate. It means large enough to show significant result, and it is achieved by increasing the power of study, and we can do this through using sample size calculation program to calculate adequate sample. It means to use sample with adequate sample size, adequate number, to show or to give significant result. Number two, to be representative. Representative, it means to represent target population. If our target population need to have, for example, male and female, it's not good to take our sample only from male or only from female. In this case, we have to do stratification of the study population into two strata, male strata and female strata, and take sample from each strata. Just say take representative sample. And also to be unbiased, it means to provide estimate close to the population parameters, as we mentioned before. Estimate means the character of the sample taken to have to be close to the population parameter, and we can achieve this through randomization. And the last two properties can be achieved by sampling method to select representative and unbiased sample. Incorrect sample size will lead to, if it is smaller than supposed to be, it leads to poor quality research and wrong calculation. But if it is larger than supposed to be, it leads to wasting of the resources, including money. So sample size calculator to calculate adequate sample. There is more than one sample size calculator. Number one is standard statistical software, for example ABinfo. Number two, manually, we can calculate sample size manually using equation and by nomogram, also by tables, and from Google there is sample size calculator.
So after we learned roughly how to do sample size calculation to choose the sample adequate enough to give a significant result, we can now know how to do sampling method in order to achieve the other two properties, to have a representative sample and unbiased sample. In the beginning, we have to know the classification of sampling methods. Sampling methods, it may be probability samples or non-probability sample. Probability means every unit in the population have a chance of being selected in the sample. In other words, that each unit is probable to be chosen in our study sample. So the types of a probability sample is systematic sample, cluster sample, simple random sample, and stratified sample. And the results of this type of probability sample can be generalized on the whole population, as there is randomization, as we say. So the other type is non-probability sample. Non-probability means that some units in the population have no chance of selection, or where the probability of selection cannot be accurately determined. So not all the units can appear in our sample. The examples of this type is convenience sample, judgment sample, quota sample, and snowball sample. And of course, the results done by this research, or the research done by this type of sampling technique, the result cannot be generalized on the whole population because there is no randomization.
So, as we say, sampling method, non-probability and probability. We'll start by non-probability sampling method by convenience, purposive, or quota sample. Convenience sample means accidental sampling. It is non-representative sample, and it is haphazard selection based on relative ease of access. It aims to explore or to get the feel of situation. But from the result of research done by convenience sample, we cannot generalize the result on the whole population. And the example of it, like we take the first 10 patients in the clinic and do our research on this 10 patient or 100 patient. Like we take the patient who are easily accessed to us, or we take the student who are in the library, or we go to certain restaurant and we take the whole attendance of this restaurant and do our research on them. So in this case, it is non-representative sample. The second type of the non-probability sampling is purposive sampling. It is also non-representative sample for or of a large population. It aims to serve a very specific purpose. That's why its name is purposive sampling. The researcher targets a specific population, for example, the manual workers. He is unable to specify them because they don't know actual number of these manual workers. In this case, they take or interview the available subjects. Its name, purposive sampling. One example of this purposive sampling is snowball sampling. It is chain or network sampling. As a small group is initially identified, then data are collected from them. Later, they are asked to recommend or to recruit others who have the same experience under investigation. That's to say, the first respondent refers a friend, the friend also refers a friend, etc. And its name snowball because it is similar to snowball. Once it is rolling, it picks up more snow along the way and becomes larger and larger. It is used when the potential participant hard to find, so the researcher asks the first participant to recruit his friends in the sample. The third one in non-probability sampling is quota sampling, in which a population is first divided into subgroups as in stratified sampling. Then judgment is used to select subjects or units from each subgroup based on the specified proportion. That's why the other name of quota sampling is judgment sampling. For example, an interview may be told to sample 200 females and 300 male between age of 45 and 60. And as we see, it is also non-representative sample. We can't generalize the result coming from this research on the whole population. On the other hand, probability or random sampling method, in which every unit in the population have a chance of being selected in the sample, and this probability can be determined. Randomization plays an important role or two key rules in the sampling, as it produces more matched groups when we use two or more groups. Through randomization, we can do matching of these groups. Number two, it permits a valid statistical analysis. The types of random sampling methods are simple random sample, systematic sample, stratified random sample, multi-stage sampling, and cluster sample. As regards simple random sampling, in which a population should be uniform or homogeneous, and each unit in the population has equal and independent chance to be selected. How can we do this? First, we list all the units in the population randomly in the sampling frame, and this is important point. We have to take care about sampling frame. We do sampling frame in the simple random sample, and then we select the required number using the random number table. The advantage of this sampling technique is simple to conduct, but the disadvantage is that it requires sampling frame, so we have to know the whole population to be studied, and it is unsuitable for heterogeneous population. They are heterogeneous for age, gender. That's why we have to do them in the form of strata, as we will mention later. This is through using table of random numbers, number of all the people in the population, then use the table of random numbers found in the statistical book or in the websites to identify which individuals to be selected. For example, if we need to select 50 subjects, first we select starting point. The first two-digit number is 68. We can't use it because the population are 50. So the next number is 48. As we see, we can use this number and then continue until the sample is complete. Also, we can use SPSS, Statistical Package for Social Science program, to generate random sample. The second type of probability sampling or random sampling is systematic sampling. Systematic sampling, also we do it from sampling frame, so it needs sampling frame it means that we have to put the whole study population in sampling frame, and we have to know all of them. For example, if we want to select 100 subjects from sampling frame of 1000 study population, so we should select one subject from each 10. The first subject is selected randomly, then select other subjects at regular intervals. For example, if the first subject is the 5th one, then the selected subjects will be the 5th and 15th and 25th and so on. The advantage of systematic sampling is it is easy to conduct, while the main or the most important disadvantage is that it requires also sampling frame, so we have to know the whole study population. Also, it only select the first subject randomly. We don't select the whole sample randomly, only the first one is selected randomly. The third type of random sampling or probability sampling is stratified random sample. It is used when the population is heterogeneous. As you remember, the first one, simple random sample, the whole population supposed to be homogeneous in age, in gender, in occupation, and so on. But here, if the population is heterogeneous, we can't use a simple random sample, but instead we use stratified random sample. That's why, or that's to say, people in the population differ as regards some characteristics. This characteristic relate to the factor being studied. And in this case, we divide heterogeneous population into homogeneous strata, then select simple random sample from each stratum, and proportional allocation should be represented. Proportional allocation should be represented or respected in the form of, if we have, for example, the number of female double number of male, in this case, simple random sample from the female will be double simple random sample from the male to be representative. The advantage is that the most suitable procedure to ensure representativeness, because we divide the heterogeneous sample into strata. But the most important disadvantage is that it is more expensive and time consuming. The fourth type of random sampling is multi-stage sample, and from its name we divide the study population into stages, or we take the sample in the form of 2 or more stages. For example, two-stage sample of school children. In the first stage we take random sample of schools, and then second stage we take a random sample of children from each selected school, and it may have more than 2 stages. For example, selected town, and then selected district from each town, and then selected streets from each district, and finally houses. The advantage is that it concentrates resources, because it decreases the number of individuals on which we do our study. And also it needs no sampling frame, no need to do framing of the whole study population. And only a list of the first stage unit is required. Frame is needed only for the selected last stage units. The last type of random sampling is cluster sampling. And from its name, cluster means group of population or group of schools. Cluster means group. So the sample unit is not individuals. Sample unit is a group, not an individual. For example, family, school class. They are selected randomly from all groups of the same type, and all the members of the selected group will be included in the study. So the advantage is that field is concentrated and it is simple and cheap, because we just choose the whole cluster, the whole group of individual. but its disadvantages that it causes errors or bias if the studied disease or variable is clustered in the population, like it's clustered in the group in which we didn't choose, or it's clustered in the group we choose. In this case, it gives bias of a higher prevalence of the condition or the problem, or lower prevalence according to the cluster we choose. What about random allocation of subject in clinical or interventional trial? In this case, we want to allocate the subject in group A or group B or other groups randomly. In this case, we can use simple randomization or blocked randomization. In simple randomization, it can be done through tossing coin, lottery method, random tables, or computer programs. So, for example, if we have two groups, group A and B, if we use tossing coin and it appears like head, we put the participant in group A, and if it appears tail, we put the participant in group B, and so on. The advantages that it is easy, but the disadvantage that we find or result in two imbalanced groups, as most of the participants can be in group A and others will be in group B, because most of the participants, if we use, for example, tossing coin, it appears in the form of head, so we put them in group A, and the others will be put in group B. So if they are found, for example, 100 participants, maybe 70 in group A and 30 in group B, and this appear or results in two imbalanced groups. Also, we have to avoid alternating assignment of subjects. For example, A, B, A, B. If it appear, for example, from the beginning A and then second participant in B, and then if the investigator use this pattern continuously, in this case there will be bias, because allocation will be known in advance. So we have to avoid alternating assignment. The second type, and this is better than first type, is blocked randomization. This can result in two balanced groups, and this is the main advantage of it. Two balanced groups, like equal number of subjects in each group. If block size is 4, so 2 allocated to treatment A and 2 to treatment B. We have 6 combination: AABB, BAAB, BBAA, ABAB, BABA, and ABBA. So we select only one from these combinations randomly. We put all these combinations in the lottery method or in a computer program or whatever. We can select one of these combinations randomly, and then the 4 subjects are assigned to treatment accordingly. Repeat this procedure until the required number of patients is allocated to treatment. So every 4 patients, we select from them one of these 6 combinations. For example, for randomization of 100 patients, repeat block randomization with block size 25 times.
Thank you and keep well.